Now we will continue with Ignacio Lacalle. He is a researcher of the Polytechnical University of Valencia, working in the lab of real-time systems with distributed nature and its applications. He has been working developing the IoT platform and tools of the Pixel project. So,
yeah, thank you very much, Salvador. I don't know if you are able to see my screen well. I would assume yes.
Yes.
Thank you very much for the kind presentation, and thank you as well, Bib, for the previous presentation, which has been really exciting and enlightening. So congratulations on that side. I'm here, as Salvador has said, I am Ignacio from the Universitat Politécnica de Valencia, Polytechnic University in the southeast of Spain. And we are the entity which is coordinating and has been coordinating for more than 2 years already the Pixel project, one of the projects funded under the Mobility for Growth Ports of the Future call, as well with Coriolis and Port Forward. And our project, Pixel, stands for Port IoT for Environmental Leverage. So before showing you and explaining which is the tool, what I would like to explain you today, I will make a little introduction on what this is about and what's Pixel actually. As I have said, Pixel stands for Port IoT for Environmental Leverage. And knowing from the title, our main aim is to deploy IoT solutions to European ports to drive them towards the ports of the future. One of the main characteristics of our project is that since the beginning, we have been focusing on delivering tools aimed and targeted to let the long tail of less well-funded ports in Europe, meaning not the top ports in container reception and tons per year, but the small medium ports in Europe, which are more than 600, to allow them to access open source IoT solutions that will be able to drive them towards the ports of the future. Why did we do this? Since the beginning, before the project, we realized from previous experiences, having conversations with ports, with stakeholders in the maritime sector, we realized that there is a hindered potential value in a lot of data that is available currently at ports or may be available very soon with the growing interest and availability of sensors, hardware, and IoT techniques that is currently not being exploited because certain reasons. Because it's a lack of communications in between departments of ports, lack of communications between stakeholders, information is in isolated silos of systems, not connected and not interoperable for community systems, terminal operator systems. There was a lack of end-to-end controls. There was not a clearly defined heterogeneous form of defining data formats for compiling them together. Also, the port market was not clearly ready to have this kind of solutions. Well, I could be here a lot of minutes talking about hindrances that drove us to propose Pixel. So this led us to certain challenges to address, which were mainly aiming at having ports closer to implementing innovative actions from current data, exploiting it, extracting valuable information to apply new policies towards environmental impact reduction or port-city interaction, traffic congestions, or other solutions. So after realizing this scenario, we proposed Pixel to be as a centric element for integrating and letting ports give this step forward. The technological basis behind Pixel are having a data sources interoperability, using consolidated IoT technologies and techniques, all together with semantic annotation and aggregation of data. Driving ports towards the centralized management of the data on a unique platform to see and be able to correlate and have in a unique platform the data to be analyzed and observed. So to have Pixel become both an integrator and a tool for mainly port authorities, but also to other stakeholders in ports, and thanks to our security, access, authentication protocols, etc., being a tool for democratization and awareness of the port operations, port data, port information, what is going on in the port, having different stakeholders acceding to the information, be able to make decisions upon them. So as it goes and it states in the title of this slide, Pixel proposes to drive digitalizations toward the ports of the future. Pixel is a project that has been running since May 2018. It's more than 2 years by now. And our aim, and since it was proposed, is to deploy a series of tools atop of the IoT technological basis, which is in the base, build atop a certain of innovative solutions and use cases to be deployed, tested, and validated in real pilots across different European ports. The ports that have been participating and are currently participating in our project are Port of Bordeaux in France. It is aiming at applying different IoT techniques related with making a kind of digital twin modeling port operations related to the terminal operations in order to optimize energy management. We have the port of Monfalcone in the north of Italy, which altogether with a dry port in the border in the country with Slovenia and Italy, which is Gorizia, have their intermodal connection both with train, rail, and in the water side vessels. So it's an intermodal use case transport in Italy. And we have two use cases in two Greek ports, which are Port of Piraeus, which is a big one, and Port of Thessaloniki, which is a medium one, centered on the port-city relationships, specifically on the traffic congestions and the influence of touristic buses on the cities coming from the port. And finally, and focusing already on what I am going to explain today, the Port Environmental Index use case that is being implemented and deployed in all the pilots and all the ports participating in the project. What is this Port Environmental use case about? Well, it is about establishing what we consider a flaw, a shortcoming in the current state-of-the-art for allowing ports toward environmental impact reduction, which is effectively measuring the impact. Before applying any measure, actual measure, physical measure in the port to reduce environmental impact, one port should be able to first measure which is being its impact, decide which action to tackle, and afterwards measure the impact of this measure taken. So, drawing from what we have delivered and what we have designed and deployed regarding the IoT platform, we are applying it into the ports, into the 4 different ports in the project, integrating already existing sensors that were providing information regarding the environment. For example, noise measurements, light pollution measurements, air quality measurements, and others. We are gathering them together, putting into the Pixel dashboard tool and IoT tool. We have deployed a certain of mathematical operations and toolbox to build what we have called a single indicator measure for facilitating green policies. which is the Port Environmental Index. This index aims at reflecting what a port is impacting the environment with their operations, not just measuring which is the air quality now, because that will be just as easy as putting one sensor measuring the PM10 or the CO2 pollution, but to having enough tools and enough construction to build a representation in an index between 0 and 1 to measure how much our port is consuming. This entails a lot of considerations, a lot of rationale behind to build that in that one index. For doing so in our project, this action has been led by a top research environmental group in Croatia, one university-based with a lot of environmental expertise, which has helped us to build this index. Technologically, which is what I'm depicting here in this image, we are basing our tool on gathering different information from different sources, for example, forms, web apps, APIs, sensors, different information that can provide us useful data regarding the environment. Following the structure of the tool we have developed in the project, the IoT architecture, all the data is gathered using an open source tool based on firmware, which is called Orion. Everything is stored and therefore it is computed using a complex mathematical toolbox to calculate and estimate which is this impact in a retrospective way, and therefore the results are shown in an interface, which is the one that I am going to show you, which has this aspect. I would like, if I have some time, I guess so, I would like to try to show you, stop sharing and try to show you the actual tool, because it's deployed in, well, and it's available. I want to make this a little bit more dynamic, as well as Div has done. These are the results of our tool. In order to understand which is this index is gathering certain data for emission of the ships, plastics that the port, some wastewater that the port is contributing to the environment, for example, this municipal solid waste that the port or the terminal activity is generating, the inert waste generating, the noise pollution, the light pollution, following a rationale already established with clear environmental rationale has been constructed. Certain weights, certain normalization strategies have been established, defined, and implemented to step by step, level by level, construct real-time changing values for representing which are the air emissions being impacted to the environment by the ports, from the terminal, from the port authority, from different stakeholders, and finally coming up to a visualization of which is impact is being impacting the port. Sorry, this is taking a little bit longer than expected. Yeah. So with the tool we have developed, we have a single indicator which is comprehended between 0 and 1, can be seen here, that reflects at every moment which is the current level of impact the port is having towards the environment, coming from a bunch of different data sources. What we have developed will allow also the port to check which has been for different days of the week in different kind of measurements and grouped by specific sub-indices we have defined. So this tool will, at the end of the day, allow one port to check during the time how this has changed in order to check how new green policies have been impacting, if they have been useful or not, and as well to compare with other ports, because we have been following clear, standardized, and mathematically reasoned strategies for normalizing all these calculations. Coming back to the presentation, sorry, and to end, We are aiming, or we are in the path of having this tool totally completed by the end of the project. We will be next year, and hopefully by then we will be able to make this available for you to play with and observe more closely how this works. For now, for what regarding the feedback we have been received from ports and what can be confusing of what tool and what not, I have depicted this small slide to clarify what this tool is or is not. This tool aims at being a single indicator to reflect how much a port is impacting the environment, allowing a port to comparing the environmental impact with other ports and throughout the time with themselves, aims at being an affordable open source tool, normalized per cargo, and able to be used by any port size independently, it's a big port or a not that big port, small or medium. It's a real-time software tool powered by IoT sources, different data coming to it. What is not, it's not aimed to be an auditing tool for punishing ports upon environmental sanctionable issues, which are things that have been asked to us before. And yeah, more or less this is what the summary of our tool is. Of course, I will be open to any question this may arise for you. Here I have dropped our website and our common social channels. I invite you to follow us. We are pretty active of them. And of course, I invite you as well to subscribe to us in our newsletter and to contact us with any question arising out of this presentation. Thank you for the attention, and I am open to any question.